would you please welcome Norm Springate, who is going to talk on the impact of reconstituted wood.
Gentlemen, I think the first thing talking about reconstituted wood is to tell you what it is. My definition is it's probably any kind of wood that we take apart the tree and put it back together again. And in that grain, I would say that plywood is probably the first reconstituted wood that we are aware of in this province at least. And it is a case where we actually take the wood apart by making it a veneer using a resin, phenolic or urea or whatever to put it back together again, and that becomes a product. That is a product that has been in this country probably since the early 20s, when there was the first one that I am aware of with a mill down in the old Burnett River, which processed cottonwood and used kerosene glue, and actually didn't have a dryer. They actually dried the panel while they pressed it, which seemed rather an interesting way to do it. But it did work. It did make a product, but they went broke because I think they were probably ahead of their time. The next plant probably was the Canadian Western plant, Fraser Mills, which was probably also built in the 20s. Then up into the 30s with Macmillan and Touchlight with, again, we were changing the resin then, those days, into the phenolic resins. And then the plant that I was connected with in 1939 was the Canadian Forest Products plant, where we actually reconstituted birch, veneer into aircraft plywood, and followed that after the war with fir veneer, again, as all the other plants were doing, into a plywood product. Then in the late 40s, we started in what the product which most of you would maybe think would be more reconstituted product, which was the wet process hardboard. That is, again, as most of you know, breaking the wood down from chip form into fiber and building it up using a wet process and a minimum amount of resin, probably half to 1%, and using its own lignin binders to build it up into a panel product. That plant was, I think, one of the earliest. We went through lots of problems trying to learn something about the business. It has proved to be very successful and is still one of the big contributors to panel products in not only Canada but in North America. I would say it was the first. Then following that, in the mid-50s, a particle board plant was developed. Particle board, again, being a product where we take the sawdust and the shavings, hammer mill them, and break them down into smaller pieces, usually build them up with a urea resin as against a phenolic resin, and building them into a board product in that manner. The first plant was on Lulu Island, across from an old cedar mill, BC Manufacturing, which many of you may remember. That plant actually was built by the Fall River Company, and as a matter of interest, it failed. But the plant was then moved down to the present K3 plant in Macmillan Liddell's operation. That plant is still operating and making quite a good board. This is one of their products and quite satisfactory. That brings us up to the mid-50s. Towards the end of the 50s, not in BC, but in Saskatchewan, came the next product, which is the wafer board as we know it today. That plant was started to build around 1959, developed from processes that had been developed in Washington State, and it was designed to break down the aspen weedwood product, cheap product because no one knew what else to do with aspen, and it was flaked by machines built here in Vancouver by CAE, disc and built up into the wafer board product as we know it today. I would say it was probably the first successful wafer board plant in North America, though there was a forerunner in Sandpoint, Idaho. The plant, of course, like many plants, when they're first failed originally, it was developed by the Saskatchewan government, and then it was taken over by Waddell, and they were able to bring it onto the market and successfully introduce the product into Canada and the USA. The next stage of development after wafer board is a process that has not been to Canada or BC, which is medium fiber board, which is a product similar to wet process wafer board. However, the fiber is dried before it is formed. Consequently, the moisture is taken out of the fiber mat, and it is enabled the pressing times to be somewhat shorter than the wet process hardboard. Both products use defiberizing equipment, Aspen, spout welders, or others, to make the fiber into the form that is acceptable into that board. It has very good machining properties, probably better machining properties than the particle board as we know it, and it is a very acceptable product in the furniture industry. Following that, now in the mid-60s and into the early 70s was a development by Potlatch Forest in Lewiston, Idaho, where they decided they would take a insect-killed forest and try to convert it into a useful product. They did that by taking their material from these dead forests and poor grade logs and making them into what is called a maxi chip. A maxi chip is a chip about twice as long as a normal chip to give a length about 2.5 inches, maybe up to 3 inches. And these chips are made in such a way, screened out all the lot, and then put into ring flakers so that they can make a strand being like a matchstick, such that you've got some length, you've got narrowness, such like, and they built that into a panel product which was oriented across the 4-foot direction, as you can see here, and that was made as a core board for veneer and made into a plywood-like product, as you can see here, with the veneer faces on face and back, thereby extending their wood supply of peelable required wood and using up a material that was not considered desirable for their pulp mill or for any other use. The product, known as ply strand for their terminology, and comply as a genetic term for the product, is becoming accepted, very well accepted in the USA. The second large plant has been built now in Dudley, North Carolina by Georgia Pacific, and every indication is that they are quite satisfied with the way this product is working. But it, as I say, it did take almost 10 years to develop that product up into what we're talking about today. The next product, which as yet has not been introduced as a commercial product, but is very highly talked about in America today, is what is called OSB, which is oriented strand board. Oriented strand board means that we have this core board as we see it, but with the grain in this direction. But then over top and bottom are the strands laid, oriented, so they're in the same direction as plywood, and they will approach plywood quality. So there you have a run of the history of a board, a reconstituted board, for a span of about 30 years. On top of that, we have been looking at plywood also, and going back to the veneer stage and saying, what else can we do about that? And there is laminated veneer lumber. Now this is designed to use inferior species. The peel is to 1/4 inch in this particular case. And we have done work with the BC government in developing aspen, known as a weedwood if you wish, up to the strength qualities of Douglas fir for certain truss uses. On top of that, we have another product which combines the particle board aspect of what I was discussing earlier, like this part of the board. Here is a product which is very interesting, though you can't really tell by looking at what it is. It's actually a joist. This is a 2x8 joist, which is made of an interior particle board core, phenolic bonded, and on the surface of it, we have 4 strands of this high-strength product, which is laminated veneer lumber with all of the grain direction in the same direction. Consequently, there's no cross grain to give any weakness. So here may be a product of the future where we are combining some of these reconstituted wood products into forms that are designed to give a interesting lumber product and again be substitute for the true solid wood product as we know it. So we're looking to the future, of course, and this is why we're talking reconstituted wood. When our wood supplies run out, which they will never do, but they may in the log quality that would make the lumber we want, we have ways now of making the joist portion of a house out of a reconstituted product by combining 2 or 3 technologies into one. And there may be more coming all the time. One thing that's coming is very interesting is wafer board pallets, where they actually press the wafer board with a mold so that one step you have a pallet which is very acceptable where you want it to be completely insect proof and such like. That will be one of the aspects of the future which some of you may have read about. Okay, that is the history, which is, let's say, in our province here, it spans about 50 years. So you say, why did it happen? Well, you have to look at raw materials. It didn't come in this province as early, possibly as some other parts of the world, particularly Europe, where some people here that I know did work on this back in the 20s, where they were developing particle board because they didn't have the resource like we have here. Actually, the boldness of Canadian forest products in 1949 to go into a reconstituted product was rather visionary because they could have sent their chips to pulp mills or whatever, but they chose to look at a reconstituted product then, and it certainly had to be very successful. So what do you make this out of? Well, I dwelt on it a bit as I talked about these various products. Round wood is one way to start, obviously. The wafer board is normally cut from a round wood because you want as good a flake as you can get. These flakes are aspen flakes cut from round wood by disc vaporizers, and they will give a panel a good strength pattern. Particle board can be from shavings, sawdust, hammer milled, or prepared and screened properly to give a good bonding agent. If you use the short fiber, as you would in particle board, you must use more binder to give it the strength qualities you want. If you do for example, we could have 8 or 9% resin in some of this type product, which is a particle board, quite thick, but a particle board nevertheless. Obviously, sawdust and shavings are residue products, and they have a very low value. And I think one of the things we've got to keep in mind in reconstituted wood is you've got to start with the lowest cost raw material you can possibly get. The other one which I dwelled on was chips. You can take chips, as is done in the hardboard process, the MDF process. The chips are broken into fibers which will knit well together, give a rather good yield because you're not trying to dissolve them as you would in paper, and build them back together with usually a urea resin, which is not a structural product, but probably in that case, 7 to 8% urea resin is blended in with that material, and it is built into the furniture components. One other, and I mentioned I dwelled on the maxi chips. Now, maxi chips could come from in woods chipping. Thinning of small trees could yield a maxi chip. We can probably tolerate a small amount of bark, as long as our binding and our fiber length is satisfactory. The maxi chips we have made from head rig chippers. This came from the southern pine area with head rig chippers, more bark in woods chippers, and then going into the rig quakers as I described for this core product. We have to remember in all of these reconstituted products that the better the flake, the better the board. The better the flake or strand or wafer, and each of those names really means something. You have to try to think along the lines of the fact that a wafer is quite a wide, flat piece of wood. The strand is narrow and long, and particle, of course, is what is described as being a smaller and more filling type of material. Okay, that's where it comes from. Where do we go then? I'll review rather briefly, but try and cover the field in how we put these products back together. We start, of course, by bringing in the log, either an 8-foot length, which is very popular in most of the mills in Canada, particularly in the waferboard field. The 8-foot length is logged into the plant. There is a trend towards tree length logging where you can actually merchandise that wood, and even in the hardwoods today, you're finding that there is a desire to get the lumber log out, the peelable block out, and such like, and this is happening with the lower grade part of the wood going into the whatever process you are choosing to use to make the product you're looking for. Brown wood, of course, is desirable, as I said earlier, for the wafers and the strands. And the first thing you do have to do after you've broken up the wood into its various components, taking the high grade out, then your lower grade or your acceptable grade will be debarked, of course. But since a lot of our plants in Canada are in the freezing zones, Hudson Bay, for example, all the eastern plants, the first thing we have to do is condition it to thaw the log first in that time of the year when you have to do it. Most of the species, like aspen, which is so popular for the waferboard product, does not have to be conditioned for most of the year, but it is primarily conditioned to get the frost out. However, we are running into other species that require conditioning during all of the year. We have been working with some southern species where the pecans, hickories, oaks, and such like, where we are still learning a lot about how we can wafer, how we should condition, whether we should condition, but we believe it to be a very important part of the process to be sure that part of the job is done well. You can condition too much. I suggest you can condition too little. There's times when you maybe shouldn't condition at all. I think one of the major situations is good fresh wood, no matter what species it is, will probably flake or cut the bed. After conditioning, and you can use chests or ponds, there's lots of ways of doing it, but still lots of consideration. Okay, so we start the conditioned wood into the processing method. We'll just talk briefly about chips. They go into the aspen vibrators or equal, where they are pre-cooked, slightly softened under pressure, and ground by face discs in contact with each other and then blown into more refining and such like for both the wet process goes into wet process vats, the dry process goes into bins and such like. The other processes all require knife cutting. And we have drum flakers, which can be 4 to 6 foot in length, so we can take that length of wood into the hoppers that are fed in against the knives in the flaker. We have disc flakers that do the same thing with force feed in from the side against the discs. And we even have some kinds of flakers where the wood stationary and the knives move across the stationary wood to make the flake in that manner. So there are many ways of doing it. Very important that you choose the right one for your wood, your process, because again, as I said earlier, the better the flake, the better the product. And often the better the flake, the lower revenue you might have to add to give the same strength characteristics. Now, we are watching very carefully what kind of flaker, a drum or a disc, will make the most uniform thickness of flake, because thickness variation can cause problems. We desire in many cases 15 thou, 20 to 25 thou, and maybe the core, maybe a different thickness in the face, and there's many combinations of the theme. Therefore, you must be very cautious of how you choose that equipment, and it does take quite a lot of consideration. Mills are making final products, wafer board, oriented strand with both methods. So drum and disc and whatever. So basically, that is the initial breakdown. I have talked a little bit about the maxi chip going into a ring flaker. A ring flaker is a device made by Paul and Company or the Meyer Company, where there's internal ring of multi-knives, about 8 inches to 10 inches in width, depending on the capacity. The maxi chip goes in the center. Centrifugal force takes it to the outside and forces it in slots so that these multi-knives can render it into flakes as uniformly as possible. The potlatch, for example, have 4 of those flakers in a row to make the product they are doing. In some cases, with the particle board, you actually use a hog to break up the shavings, take the curl out of them, for example, break up the sawdust into smaller particles, and again, render it down to a common denominator. There's another machine that is just being introduced that was developed by Peter Koss in the USA, which is called a shaping lathe, where the actual knife system is on the outside of the drum, and the block is held in chunks. It makes one revolution as the large knife head comes towards it, and it can render wood into a round cylinder that would go into a veneer lathe, for example, or into timbers, ties, for example, pallet stock or such like. And the first of these machines is now being introduced and will be in operation in May or June in the Normic plywood plant in Lassar, where they're going to take the well-made flake off the outside of the log and put it in a wafer board plant that's adjacent to the mill, and the rounded up block will then go into the veneer lathe. And again, we believe that will at least give them 1/3 more productivity with veneer lathe, and all of the outside of the log will go into the board plant. A very interesting development. Another flaker is kind of an inside-out flaker that is being developed by Cancar. Norm Beatty may allude to it. There, the knives are on the inside of a big drum, and the wood is shoveled into it and forced out with centrifugal force, as well as the knife force, hydraulic force, making the wafers leave the outside of the disc. And in that particular case, they actually have a series of knives on the outside so that they can actually control the width of the flake. So you have many choices of how to prepare the wood for the board that you're trying to make. Screening is very important in this whole business, because when you cut wood, no matter how you do it, and of course you recognize that not only is the wood cut, it is also cut to a certain length. The length is anywhere from 1.5 inches to 3 inches. So you're separating the end of that wood from the main portion of the bowl. And in doing so, you do create fines, which are going to show up in the board as filler material, which you really don't want because it can absorb resins unduly. So you can start to screen your material in the green form if you wish. If you take it in the green form, then you are taking away need to dry that material and taking that into your hot fuel. You can use rotary screens, which are big drums, 8 foot in diameter, for example, maybe 20 foot long, of various screen sizes, in order to get this material out of your process as early as possible. Or, if you wish, and maybe preferable, you can screen after drying, because in the drying process, many of these hair-like fibers will become more brittle and will break away from the main plate and show up as dust. So that has to be taken into consideration, and a very important part of the project, because your losses could be 10, 15, maybe 20% of your total furnish might go in that direction, and that's a very big consideration. The next step, of course, is the drying aspect, and because these are all fairly uniform particles with a very large surface in relation to their size, the tendency is to use flash drying, which can be usually is rotary drum with direct heat, temperatures ranging from say 800 degrees, maybe up to 1600 if someone's pushing your dryer. And you can dry, we believe, probably it takes about 7 seconds to get through the normal dryer. But the plates are protecting themselves against burning up under that temperature by the moisture coming out of the plate. Most of the particle board plants use 3-pass dryers, which drum sizes up to 12 feet, might be about 48 foot long. There are also single-pass dryers being used where the velocity is slower and the turbulence is greater. And again, you pay your money and take your choice. At the back end of the dryer, you try to separate the flake from the dust that you have generated and has come through the process, because at the same time, you're going to be coming under pollution and environmental laws, which this is one of the most difficult areas to control. We try in most of the plants to drop the larger flake material out of the back of the dryer by putting it through a low velocity zone, and it usually works pretty good. It's an excellent separator because dust then will go over into cyclones and then multi-cyclones, usually primary and secondary cyclones, to really get your emissions as low as possible and meeting the environmental standards. It's a dangerous area, of course, because with that temperature, if anything goes along to the flow, if you break that moisture protection by something stopping, you can get fires very, very rapidly. These must be detected. You must take steps at the back of your dryer to get the fire dump area away from your main flow, and this has to be done. It works out very well if you do it, but you've got to expect that you are going to get fires in this business. The main thing is controlling your flow, handling your material properly. Probably the most important thing in any of these plants is how you store your material and how you feed it out. And I think probably the man who developed the first vaporware plant is a farmer, because what we use looks like a manure spreader, and it has a series of picker rolls at the back of it, and as you feed it up, it picks the stuff out and flows it out at a fairly consistent rate. So consistency in the drying is the way you must go. step after drying, of course, and if you choose to dry, to screen now, you should screen. Some people screen the fines into the core from the face, and some people throw them away, and some people leave them in. Just make the board anyway. This is up to your choice again as to the quality of board you wish to make. The next step is again to go into dry feeders, which I just described, and green feeders are the same. Then you have to measure what the bulk density, the weight of this material, because then you're going to start ahead to add your chemicals, and you must measure how much your wood is coming through. And we are doing it today. Other people have done it with other weight scales, but nuclear weight scales are working out very well because they can measure the bulk density, the weight of this material, regardless of the bulk density, and pretty well with the constant moisture content. To that measurement that you obtain from that information as it comes out of the feeder and works toward the blender, the resin, phenolic resin, in most cases for structural board, urea resin for particle boards and such like, is added with usually a small amount of wax to give the board a little more stability. And in the case of use of powdered resin, which is the binder that's most commonly used, the wax will help the resin attach to the wafer in the blender. The blender, under wafer board conditions, is usually a large 5 foot to 8 foot drum, 20 foot long, which tumbles the material with the powdered resin in it so that some of the resin sticks to the wood but doesn't stick to itself. Therefore, you get a thin coating of powdered resin on the wafers. There is a tendency, and Norm will be talking about it, to use liquid resins. Liquid resins could be less expensive on a solid basis, and under certain conditions, they may give a very satisfactory coverage to the wafers, although there have been fears that the liquid resin in an atomized form will not be able to penetrate some of the shadowing that the plates may give each other. We're hopeful that liquid resin will work, and I think we're learning more and more that it can be an effective bonding agency. After leaves these plates that are now attached with their binding medium, they go into forming stations, which really are basically a head that will meter material out at an even rate onto a moving caul under the forming line. The caul can be a solid plate or it can be a screen caul. Solid plates were conventionally used. Material formed like on a big cookie sheet goes into chargers and into the press. The screen caul does the same thing, but it must be dragged through and handled slightly differently. Caul going through the press system actually goes through, and the board is peeled off, and the caul returns for reuse back to the system. In the case of the screen caul, the screen actually goes through the press system with a tow bar, and it goes down under the press and comes back the other side and for reuse. Some of these boards, for example, this board, which is a wafer board, you can see on it when you examine them up here, the screen back is formed by a moving screen caul. The presses are, of course, obviously very large and of many, many different sizes. The K3 plant, for example, is a 4x8, as are all the wet process hardboard plants around here. The early wafer board plants were 4x16. The Chatham plant, which we converted from particle board plant to a wafer board plant, was 8x24 foot, and most of the plants today that are being built are either 8x16, 8x24, or whatever. Then they have multiple openings, up to say 20 in some cases. Again, you have to watch your forming speeds and such like in order to ensure that you can keep your forming rate up to your pressing rate. Now, there's other developments going on which are very interesting. which is another form of the particle board made from sawdust and shavings. And at the present time, the first plant in North America is being built in Smithers, BC, and it's a thin board product, which is this product, again mat form, but on a fabric mat instead of a screen mat, because it's a urea board, doesn't take the temperatures that will affect the mat. It is a single opening press, 8 by 24 foot long, 8 by 48, sorry, 8 by 48 foot long, a pressing cycle of about 55 seconds. We can make about 15,000 panels of 4 by 8 a day on such a press, which in that thin thickness, a product which is designed to replace the Lawan plywood that we historically got from Korea, Taiwan, Japan, and such like. The reason that press, a single opening, was chosen instead of a multiple opening was because a single opening can give absolute is, accuracy of the board thickness. And it can be controlled very, very closely because there's only the one opening to concern itself about. The multiple openings, even though they're simultaneously closed so they don't blow out, they all close together at the same rate, still have possible problems of thickness control, though really the thickness control is created at your forming line, and though many of the multi-opening presses have corner controls and such like, even thickness with possible variation of density, they probably do the accuracy you have in a thin board. The reason a thin board must be accurate is because it's designed to be overlaid with very thin plywood, and of course, if it isn't correct, when you start to sand that thing near, you're going to penetrate through. So it is an interesting concept. Another thin board concept which is prevalent in America is the Mende process, which is forming continuously this kind of a product on a large rotating drum with a stainless steel belt to take the material over the drum, through and out, back, flipped off to length. It makes a good product, yes, but there are problems making a flat sheet on a curved drum. And the feeling is that probably the single opening flat press may be the answer for a very interesting product. This product, by the way, can be overlaid, printed, embossed, whatever you want to do with it, grooved or such like. The single opening too, by the way, could make a product as thick as this, or thick. There is one single opening MDF press plant in America, which is 8 foot wide by 65 feet long. We live at 85. 85. Well, not 85. It's getting close. But that is an interesting press because you can make a medium density fireboard in very thick thicknesses there. It has radio frequency heat on it, which is the only one that I know in America, and radio frequency boosters ahead of it. And though it took an awful time to get going, it looks like a very fascinating process. So you see the pressing aspect. Another interesting aspect of pressing is that most of the presses that we are familiar with and connected with, we're using hot oil, thermal oil to heat it, because we want to get up to temperatures of, say, 400, 450 degrees, and those steam temperatures would require pressures of steam much more than we like to do. So we have been developing wood waste fired thermal, gas fired thermal heating units, and they're giving an excellent result on even flattened temperatures and such like. And because they are using wood waste fired, they help with heat balance in their operation. I didn't mention on the drying that we are using wood waste fired on the dryer to get those elevated temperatures out of products combustion. For example, in the 2 plants we're connected with, we have chosen to put in 2 lamp target units. The first in that application, and they will be in operation within the next few months. It looks like an interesting concept of taking a rather rough hog fuel and making a hot gas out of it. We could also do it by taking the dust only and using the Energex type of burner for those hot gases, and that is a very prevalent way of doing it, particularly if you do your dry screening. The next step after the pressing operation is, of course, sawing, and finishing the panel to the customer size. In many cases, we rough trim, take the loose wafers off the outside of a rough trim panel, put them back in the process if we wish, and then go to final trim size down to the 4x8 panels or what the customer wants. It may be getting more popular in America to want to use full panel sizes like 8x16 or 8x24. In fact, there is one press in America that is 8x28, planned in Grand Rapids. So you can see the multitudes of sizes and shapes and configurations, the number of openings. Opening in the Chavez plant is 11 openings, 8x24. The one we're building in Bemidji is 14 openings. Warehouse is building one in Michigan, 16 openings. So again, you're judging your press size by plant capacity and all of the other aspects of what you're trying to make.